Hi, my name is Benjamin Loh. I'm the author of Master Math Models, and I would like to say a big thank you for liking our Facebook page. Today, I'd like to share with you a short but powerful video on how to make ratio easy to remember and also to know the exact methods to solve different types of ratio questions. And this extends beyond ratio, in fact, into questions involving fractions, percentage, and so on. So if you find this video really useful, I would appreciate it if after watching the video and it helps your kids, do give us a big comment on Facebook telling telling us how much you enjoyed it and how much it has helped you. Okay, it will be awesome. And here we go. First, in ratio, we need to understand that there are essentially 5 types of ratio questions. Okay, the first kind is what we call a one variable unchanged question. All right, this is the first type. The second one is the total unchanged ratio question. The third type is the difference unchanged ratio question. And the fourth type is what we call the set or the grouping method. And the fifth type is what we call the cross method. Almost all questions in ratio will belong to one of these 5 categories of questions. But the first thing you need to know is how to differentiate one type of question from another. So in order to do that, I will now talk about the differences between each of them and how you can start to approach each of these types of questions. The first one is called the one variable unchanged question. And in the one variable unchanged question, generally, you'll be presented with a start and an end scenario where you'll be given 2 variables, A and B. In this type of questions, only one of the 2 variables, A or B, will be changed. For example, if I say to you that a simple example would be to use boys and girls, okay? And let's say we are talking about boys and girls in a school hall. So if more boys were to join the current number of boys in the school hall, then the number of boys will increase. Okay, if boys join. Now, if that is all that is given in this question, then the number of girls will remain unchanged. And so the girls remain the same. In this situation, what you want to do is to make the ratio of the girls equal. So for example, if I tell you that the ratio of the boys to the girls was 3:7, and this is the start, and I tell you that in the end, the ratio is 4:5, then in this situation, because the number of girls remain unchanged, then these 2 numbers should be the same. And since they are supposed to be the same, we will multiply this by 5 and by 7 so that both of them will become 35. What you need to do then is also multiply this by 5 and this by 7 so that you get two new numbers, 15 and 28. Now, as you can see, the number of girls remain the same, but the number of boys has increased by 13 units. In these sort of questions, generally, the question will provide the increase in the number of boys, or it could be a decrease, but the working would be the same. And if, let's say, I were to tell you that the increase is 390 boys, or 39 boys maybe, then if I say that the increase is 39 boys, then 13 units is 39. And you take it from there to solve the question. That's the one variable unchanged question. Now, we will go to the second type of ratio question. The second type of ratio question is known as the total unchanged question. For the total unchanged question, it generally looks like this. There are three particular types of total unchanged question. And the first being, the first category of total unchanged questions will be what I call the I give you, you give me question. Generally, questions like this is where two parties, A and B, will be giving or losing and winning each other's share. Because it is still within this circle or this oval, then the total amount stays the same. Okay? Let me just remove this. So typically a question like this will be A loses 50 to B, B then loses 20 to A, and so on. This will be I give you, you give me. A second type of total unchanged question will be what we call the shared gift or present question. A question like this will typically involve two or three people, A, B, and C, for instance, being three kids who share the money to buy a present for their parents or for their teacher or whatever it may be. And because they share it like this, then the total amount of money spent belongs to the three of them, no matter how it is done. So in a shared gift question, then what you want to do is, generally, if they give you a ratio, 2 is to, for example, 5, and then they give you a ratio of, say, 4 is to 10, what you want to do here is to add these two numbers together to get a total, and add these two numbers to get a total, and then equate the two totals because the total is unchanged. To equate the two totals, all you need to do is multiply this by 2, and therefore giving you 14. But likewise, you need to multiply this by 2 and multiply this by 2. Then you will get 4 and 10 here. Now, as you can see, A is therefore 4, C is also 4, and that means B is now 10 minus 4, 6, or even 10 minus 4 to get a 6, or even 10 minus 4 to get a 6. This would be a shared gift. A third variant of this question would be where A increases and B decreases by the same amount. The keyword here is the same amount. So for example, if the number of boys, taking our previous example of boys and girls, was to increase by 50 in a hall, and the number of girls will to decrease by 50 within the hall, then this increase of 50 will offset the decrease of 50, meaning to say that the ratio remains the same. Again, if I give you boys to girls, and then I were to say the ratio is, for instance, 3 is to 7, and later I tell you that this is 5 is to 6, then what you need to do is again get the total, knowing that it is based on the same total, and then after that, equating these two totals. In this case, you need to multiply this by 11 and multiply this by 10, and then do the same for the parts of the same ratio. Okay, now you can see here, I now have 33, and this is 50, and when you multiply this, you are going to get 77 and 60. If you were to look carefully here, you can see that this has increased by 17 and this has decreased by 17. The numbers are the same. Therefore, the total remains the same. That's the second type of ratio question. And this is how you recognize whether it is a total unchanged question. In the total unchanged question, the first step then is to make the total equal. Now we go to the third type of ratio question. The third type of ratio question is what we call the difference unchanged ratio questions. In the difference unchanged ratio questions, there are also three types. The first type is where you have the same increase for both parties. The second type is when you have the same decrease for both parties. And the third type is normally related to an age question. Let me explain each of them in turn. The first one, same increase, will look something like this. There are two children. Let's call them Peter and Sandra. And they are brothers and sisters. And they have a ratio of a certain amount, let's say 4 is to 5. Okay, let's say 4 is to 5. Sorry, let me change that number to make it more useful. 4 is to 7. And then the question will say that their parents will give them both the same amount of money. Let's say $100 each. And as a result of giving them this same amount of money, the ratio changes into, for example, 7 is to 9. So in this example, they have both increased by the same amount of money, and this means that their difference doesn't change. And when that happens, all you have to do is to find the difference, take 7 minus 4, take 9 minus 7, and this time you make the difference the same. To do that, again, all you have to do is multiply this, multiply this by 2, and multiply this by 3. And just like all the previous questions in part 1 and part 2, you also multiply this by 2. So you notice it's the same number for the entire line, the entire row, and multiply this by 3, same number for the entire row. If you do this, you will find that this will give you 8 is to 14 and 21 is to 27. Upon closer observation, you should now notice that this has increased by 13 units, and so has this. And so, as a result of this, we now know that 13 units is $100. Of course, this is not divisible. I'm just giving you a random number. Okay, most likely they will give you a number here that's divisible, like for example, $26. Okay, so that's one type of question. A second type of question will be the same decrease. If the amount decreases by the same, that's the second type of question. What will it look like? Let me just clear this out a little bit. Okay, so now we are talking about same decrease, the second type. In the second type of question, for instance, Peter and Sandra both have a certain amount of money, just like previously. So let's say now Peter and Sandra is 5:7. And they both go out and they spend the same amount of money. And after they spend the same amount of money, this is important, same, let's say that the ratio changes to, so let's say that the new ratio after they both spend the same amount of money is, for instance, 4:9. Now this time, the difference between Sandra and Peter is 2 units and 5 units respectively. Again, because the difference is supposed to remain the same or constant, then you should now multiply, sorry, I just lost the number. Okay, you should now multiply this by 5 and this by 2, so that the difference becomes 10 each. By doing this, you have to do the same to the parts, just like in the previous section. And this again gives me 4 new numbers, 25, 35, 8, 18. And upon closer inspection, you should notice that this has decreased by 17 and this has also decreased by 17. So in an example like this, they will say each of them may be spent $34. Then 17 units will be $34. The third type of question is the age question. And in an age question, they would normally give you the ratio of their ages in the present and the future, or in the past and the present. Let's just take one of the examples. Let's say we talk about present and future. And let's say now Peter and Sandra are of the ratio of their ages, let's say is 3:5. After several years, the ratio of their ages is, let's say 7:10, for instance. Now, what does this mean? This means that the difference was originally 2 units and it is now 3. So again, I will need to multiply this by 3 and this by 2 because the difference should remain the same since they have aged together. Okay, meaning they have both gotten older by the same amount. Again, the keyword here is same. And because of this, when we multiply the parts by the same numbers, we are going to get 9, 15, and 14, 30. 7 times 2, 10. Oh, sorry, I made a mistake here. Pardon me. This should be a 2, and so 20. As you can see, upon inspection, there is an increase of 5 units here and an increase of 5 units here. In a question like this, they will say something like, they both they would say something like 10 years later, Peter and Sandra, their age is 7:10, and previously it was 3:5. So from 3:5, it becomes 7:10, and they have aged by 10 years. So then 5 units is 10 years. So 1 unit is 2, and then you solve the question. This is the difference unchanged question. Now we come to the fourth type of ratio question, what we call the set or grouping method. In the set or grouping method, generally, what happens is they will give you the total value of a set. What do I mean? For instance, we have a question involving, say, scouts and guides. And they tell you that the ratio of the scouts and guides is, for instance, 4:7. And then they tell you that each of the scouts will sell 4, let's use a different number. Each of the scouts will sell 5 boxes of cookies, and each of the guides will sell 6 boxes of cookies. So this will be scouts and this will be guides. Now, all you need to do is multiply this by 5 and multiply this by 6 because of the 2 numbers here. After doing this, you should get a new ratio of 20:42. Now, the original ratio is based on the number of scouts and guides, and the new ratio is based on the number of boxes they have sold in unit form. So all you got to do is add these 2 numbers together to get 62 units, and this number normally represents a certain given value. What do I mean? So here, just to make it clear, I have a total of 11 children in one group or one set. And I have a total of, let me just clear this. I have a total of 62 boxes of cookies sold in one group. In questions like this, they will then tell you how many boxes of cookies were sold by all the scouts and the guides, for example, in a certain month. So for instance, if they were to give you a number like 930 boxes sold in a week, for example, then you take 930 divided by 62, and you should get the number of boxes, or rather the number if you were to take 930 divided by 62, you should get 15. And this 15 represents the number of groups or sets. And then depending on the question, you answer it accordingly. For example, if I now ask you how many scouts were there altogether, you now take 15 times 4. Or how many boxes were sold by all the guides, you will take 15 times 42. And that will give you the answers for each of those questions that I've said. This is the set or grouping method. Okay, and how do you recognize this compared to the previous 3 types of questions? Very simple. The multiplier, if you were to have noticed by now, these numbers are different. Whereas in all the previous examples, in each row, the multiplier is the same. Here, the multiplier is different. And now we come to the 5th and last type of ratio question. The 5th type is what we call the cross method. In the cross method, generally it looks like this. For example, if I were to say to you that okay, let's take boys and girls again. And then I give you a ratio, for example, 3:7. And then I tell you that the number of boys increased by a certain number, and the number of girls decreased by a certain number, as long as these two numbers are not the same, then we use the cross method. In fact, even if the word decreased here is changed into increased, as long as these two numbers are different, it is still the cross method. If I changed both of them to decreased, and these two numbers are different, it is still the cross method. So the way to differentiate the cross method from all the other methods before it is by knowing that the decrease and the increase have different values. And that's how you do it. And that's how you recognize the question. And from there, they will normally give you another ratio. So let's, for instance, say here that the boys increased and the girls decreased. If the boys increased and the girls decreased, then they may give you another ratio, for example, 4:5 in the end. So 3:7 at first, 4:5 in the end. And these are the units. There is an increase of the boys, let's say by 100, and there's a decrease of the girls, let's say by 70. Okay, now again, these numbers are random, they may not work out, but the method is fixed. So in the cross method, what you do is you will take this number and multiply it here, and then also take this number and multiply it over here. Okay, so if you take 5 times 3 units, you should get 15 units, and then 5 times 100, you should get 500. Next, if you take 4 times 7, you should get 28 units, and then 4 times 70, you should get 280. And because this is a minus sign, then so is this. Okay, and they are equal. So from here, if you were to take 28 units minus 15 units in a model form, let's draw a simple model here. And let's say that this is 28 units and this is 15 units. When I add 500 to the 15 units, I will get a longer model. And if I were to decrease 28 units by 280, I will get a shorter model. Okay, so you have 28 units minus 280, and you got 15 units plus 500. Now, as you can see, if you were to look carefully, the difference between the two models, which is here, is 28 minus 15, giving you 13 units, and then you add this value to make the shaded part. And that gives you 780. And based on this, you have to divide it to find what 1 unit is, which is 780 divided by 13. Okay, from here, you can find the value for 1 unit, and then you can solve the question depending on whether they're asking to find the boys or the girls. And that is the difference between the cross method and all the other methods before this. So again, how do you recognize the difference between the cross method and the other methods is that these two values given should not be the same. Whereas in the total unchanged, difference unchanged questions, these values will be the same. I hope this video has been useful for you. And if you need to, watch it again until you get the essence of it. and use this to help your children to understand it. Or you can just get them to watch the video as well. And if you need anything more, please contact me at 98215215. My name is Ben. I'm the author of Master Math Models, and I'll be glad to see what I can do to help our children get consistent top results. See ya.